So we're going to continue with the proofs. This is that page that we started in class today. This is the back side. Okay? So if we're given that segment CY and segment ZR bisect each other, we can look at our graph and fill in some stuff. Alright, so since they bisect, that's the same thing as if we were to say CY bisects ZR and ZR bisects CY. So if we come to ZR, we know that this is the midpoint, so we know ZA and AR are congruent. Then we can look at CY and see that A is also the midpoint because it is bisected by ZR, so we can make those congruent. Now it's important to keep in mind that we don't know that all four of these are congruent. We only know that it's the midpoint on each segment. Okay? So now we have two sides. We're going to need at least one other piece of information to know that they're congruent, and you see here that we have vertical angles. So we know that they're congruent. So if we come over and make our two-column chart, we have our statements, and we have our reasons. Okay, so we can start with what we're given. We know that CY bisects ZR, and that's a given. And we can also go ahead and put that ZR bisects CY. And that's also a given. Then we can look at what we know from that. So we know that segment CA is congruent to segment AY, and that's the definition of a segment bisector. And we know that ZA is congruent, segment ZA is congruent to segment AR. And that's also definition of a segment bisector. Then we looked at our vertical angles. So we know that angle CAR is congruent to angle ZAY. Now we know that they are vertical angles, but what tells us that they are congruent is the vertical angle theorem. So our reason is the vertical angle theorem. So now we have all of our information, and we know that triangle CAR is congruent to triangle YAZ. And if we look back at our drawing, we can see that it's side, angle, side. If we look at number 5, it tells us that AE is a perpendicular bisector of BL. And that tells us two things. One, it tells us that this line is perpendicular, so we have a right angle here on both sides. And it tells us a bisector, so we know BE is congruent to EL. So now we have an angle and we have a side. And if we look at that middle line, we know that it's, due to the reflexive property, it's congruent to itself. So now we have a side, an angle, and a side. So if we come back and do our two columns, we start with what was given. So we have AE is the perpendicular bisector BL, or AE perpendicularly bisects BL, and that's a given. From that, we were able to see that angle AEB is a right angle. Angle AEB is a right angle. We were able to see that angle AEL is a right angle. We were also able to see that BE is congruent to EL. And all of these all come from the definition of a perpendicular bisector. Alright, we're also able to see that angle BEA is congruent to angle AEL because right angles are congruent. And the last thing we looked at was segment AE is congruent to itself. And that is the reflexive property. So I'm going to come over here to finish out our two columns. So then we can say triangle AEB is congruent to triangle AEL. We know that from side, angle, side. If we look at number 6, it says that we are given that segment BU bisects LE. So looking at that, we know that this segment BU cuts segment LE in half. So we know that LS is congruent to SE. Then we know that we're given that angle B is congruent to angle U. So we can put a curve. And we know that angle LSB and angle USE are congruent by the vertical angle theorem. They are vertical angles. So we'll make our chart. And start with what we're given. BU bisects LE. That's a given. From that, we found out that LE is congruent, LS is congruent to SE. And that's definition of a segment bisector. And then we said angle B is congruent to angle U, and that was a given. And we said angle LSU is congruent to, not LSU, LSB is congruent to angle USE, and that's a vertical angle theorem. So looking at that, we have a side, an angle, and an angle. So we can say triangle BLS is congruent to triangle UES by angle, angle, side.